In this lecture, we're going to look at multi-dimensional arrays. And these are arrays that have multiple dimensions, and we can use them to store information in what looks like tabular data, for example, in 2 dimensions or something grid-like. And when we do something like this, we will use also a multi-dimensional indexing system to be able to address elements in the array. When we have multi-dimensional arrays, we don't really have the concept of multidimension in the computer memory. So in memory, data is going to still be stored in a linear fashion. Put simply, computer memory is just a huge grid of ones and zeros. And what we do to break that into little chunks, bytes, integers, or whatever, is really something logical done by the compiler to manage the memory in our computer. So the compiler is going to do the mapping between our 2D structure that we have in our array to the linear thing we have in computer memory. But we don't need to worry about that. The compiler is going to take care of that. But know that the concept of dimensions doesn't really exist in computer memory. It is just a linear grid of zeros and ones. So basically, elements in the first row here are going to start with index 0. You see it is 0, 0, 0 for the first index. Elements in the second row are going to start with index 1. Elements in the third row are going to start with index 2. And we see also we have the same things with the second index is really going to be saying which row are you in. So this is row 0, you see the index is 0. The second row is row 1, you see the second index is 1. The third row is index 2, you see that index is 2 for each element in the third row. And this can be extended on however many rows or columns you have in your 2D data structure, which is going to be a 2-dimensional array in this case. Okay, here is how you can declare a 2-dimensional array. You say int packages. The array is going to be called packages. It's going to be stored integer types. And it's going to have 2 dimensions. One dimension is going to have a size of 4. So we're going to have 4 things in there. And the other dimension is going to have a size of 3. We're going to have 3 things in there. So this is really going to occupy 48 bytes in memory because 4 multiplied by 3, it's going to be 12 elements. And each of those elements is going to be occupying 4 bytes in memory because they are integers. So in total, this is going to take up 48 bytes in memory. And again, all those 44 bytes are going to be aligned linearly in memory. This is really something you need to keep in mind. Okay, once we have this array, we might want to put data in or just print whatever is in there. But when we do something like this, notice that we are really not putting any data in here. So what we're going to have is junk. And it will look like this. We will just have junk data in, and it won't be data that we have put in ourselves. So we need to be careful about that. So let's go down here and see how we can print the data in a 2-dimensional array like this. The first thing we're going to do is to loop through the first dimension here. And that's what we're going to do. We're going to do for a size I, we're going to start from 0. We're going to loop 4 times because the size is 4 here. And this side, we're going to just loop. We're going to set up an iterator, which is called j. It's going to start from 0. And we're going to loop 3 times. And in here, what we're going to do is use the multidimensional angle brackets access syntax here. And we're going to pass in the first index, which is going to be I, because I reflects the outer dimension here, if I can say it like that. And the second dimension is going to be from the inner loop here, and it's going to represent the second dimension. So the outer loop represents the first dimension, the inner loop represents the second dimension here. And if we do something like this, we're going to be printing the elements. I really hope this makes sense. And the one thing I want to bring to your attention is that if we have a 2-dimensional array like this, we are going to use nested loops to manipulate things inside, and we are going to use 2 levels of nested loops. If you have 10 dimensions in your array, it is possible to do that. You're going to have 10 levels of nested loops to manipulate them. Another thing I haven't really talked about is that if you try to print the size of packages, what you're going to get is the first dimension here. Because really, a multi-dimensional array is an array of arrays. So you're going to get the outer array if you try to do something like this and print the size. This is something you need to keep in mind, and we will try it out in Visual Studio Code, and you're going to see that this is actually true. Maybe you have noticed, but we are using hard-coded values in here to get the sizes of these dimensions. But this is really not good, because if the dimensions of the array happen to change, we will have to hunt for our loop here and go in and manually change these values. That's really not convenient. That's not a good way to do things. What we want is something like this, where we're going to be deducing the size of the array using the stdsize utility we have in the C++ standard library. So we can use that. But there is something you need to be aware of. On the outside, we're going to be interested in getting the outside size, the outside dimension size, I should say. And as we get nested, we're going to be trying to go and reach for the inner dimension as well. So what we're going to do in the inner loop here is use stdsize and say packages and grab the inner nested dimension. I really hope this makes sense. This is going to give us the inner dimension that we are interested at this level of nested loop. And if we go inside the loop, we're going to use the multidimensional index syntax here. We're going to put in I as our first index. We're going to put in J as the second index. And this is going to be manipulating the element we want in the array. And again, the compiler is going to do the mapping between this syntax here and the linear structure of ones and zeros that we have in memory here. So keep this in mind. Okay, if you do something like this, you're going to get data printed, and you won't have to manually keep track of the size of the array. And this is really cool. I like it. Okay, the array we have declared so far has been uninitialized. But it is possible to initialize the array when you declare it. And you're going to use a syntax like this. And one easy way I have to try and understand this is to think of this array as something that contains 4 things. Okay, we're going to have 1, 2, 3, 4 things inside, and each of those 4 things is going to contain 3 things. Okay, so 1, 2, 3 elements. And once you have this way of thinking in your brain, it's really going to be easy to think about this array here. Okay, it's a container or a collection that is going to contain 4 things. So 1, 2, 3, 4 things. Each of those things is going to contain 3 things. And you can use this curly braces and nest them to really have this structure. And it is really cool. If you know JSON, this syntax is really like JSON, and it is easy to understand once you get used to it. We can also declare and initialize a 3D array. We have 3 dimensions here, 7, 5, and 3. And again, that way we just talked about of thinking about arrays still works. We can think of this as a collection that contains 7 things. And if you count here, 1, 2, 3, 4, 5, 6, 7 things. Each of those 7 things is going to contain 5 things. You go n, 1, 2, 3, 4, 5. Each of those 5 things is going to contain 3 things. And again, we have 1, 2, 3 in here. And once you do this, it's going to be really easy to initialize your data using a syntax like this. Once we have a 3D array like this, if we want to manipulate it, for example, if we want to print it, we have 3 dimensions, so we should really have 3 nested layers of loops. And we can do something like this. The outer loop is going to be working on the outer dimension. The second layer is going to be working on the second dimension. The third layer is going to be working on the third dimension. And inside, we're going to use a multi-dimensional angle bracket syntax to access elements in our array. And again, the compiler is going to match this to the linear structure that we have in computer memory. Try to take a moment to think about this. One thing I should mention again, for the second dimension here, you see that we are using stdsize. Inside, we are targeting the second dimension. We are going to say house block, the name of the array, and target the indexing in there. For the third nested layer of loop, notice that we are targeting this third dimension, and this is how we target it, and we're going to go inside. Try to look at this, try to understand this, and if you do things like this, you're going to get your data manipulated in a 3D or 2D array, and it's going to be really cool. Another thing you can do is omit dimensions out if you are declaring your array. For example, here we have a 2D array. We can omit the first dimension here and let the compiler deduce it. One thing you cannot do though is omit all the dimensions, because then the compiler doesn't really have a way to deduce your dimensions. Here the compiler is able to deduce the first dimension here because it can count the things we have in there. Okay, so it's going to look at here, it's going to say in the second dimension I'm going to have 3 things. So it's going to count 1, 2, 3, 4, 5. It's going to say in the first dimension I have 5 things. So size is going to be 5. That's what it's going to deduce. And you can print this out using std size like we have seen, and it is going to work. We can also do the same thing for 3D arrays. The first dimension can be deduced by the compiler, and again, it's going to see how many chunks of 5 things that in turn contain 3 things that I have inside me. So it's going to look and say 1, 2, 3, 4, and it's going to deduce the first dimension size to be 4, and we can manipulate this using 3 levels of nested loops like we have seen before. Another concept I want to explain before we head over to Visual Studio Code and try this out is autofilling. Okay, if we look at the array we have here, we're going to contain a number of things, and those things are going to be 1, 2, 3, 4 things. Each of those things is going to contain 5 things in turn. So we're going to go 1, 2, 3, 4, 5. And for example here, the second block here has only 1 element. The remaining 3 will be autofilled with 0. This is what we mean by autofill. The compiler is going to see the remaining elements that you didn't initialize, and it's going to autofill in zeros, and it's going to do that for the entire array here. And if you want to manipulate things, for example, you want to set data in your 3D array, you're going to be using syntax like this, and it is going to work. Okay, we have spent a lot of time explaining these concepts because they can be really confusing for people, especially beginners, but I hope now it is clear. Now we're going to head over to Visual Studio Code and actually try this out. Okay, here we are in Visual Studio Code. The current project is multi-dimensional arrays. We're going to grab our template files and copy them. We're going to put them where they belong. Let's do arrays and multi-dimensional arrays. We're going to put that in place, and we're going to open this up in Visual Studio Code as we always do. Multi-dimensional arrays, let's open this up. We should have a main CPP file. We take out what we don't need, and we're going to jump into our main function here. The first thing we want to see is how we can declare a 2-dimensional array. So we're going to say int, and we're going to say packages, and this is going to be the name of the array, and we are going to put in 2 dimensions. The first dimension is going to be of 3, the second dimension is going to be of 4, and this is how we say it. And after we do that, we're going to end this with a semicolon. This is valid syntax in C++, and what it's going to do is set up 12 locations where we can store ints. This is really what it's going to do, but the compiler is going to know that it should allow us to access those things using multi-dimensional angle bracket notation like this. And this is very powerful because we can treat these memory locations as a 2-dimensional data structure. Once you do something like this, the second logical thing you want to do is to manipulate the data inside. You want to be able to store data in or read data that is inside. But one thing you should notice is that we haven't really initialized this thing. We just declared the array, so we can expect to find in junk data. But no problem, we are learning, so we're going to try and print whatever is in there just to show you the syntax you can use to print things from a 2-dimensional array. And we're going to use a bunch of nested loops to access the data in here. So let's read data from a 2D array, and we're going to use a bunch of loops. So the first loop is going to be looping over the outer dimension here, which is going to be 3. So what we're going to do is say for size t and say I, we're going to start at 0, and we're going to go until we hit the end. We want to loop 3 times, so we're going to say I less than 3, and we're going to increment I. And inside, we're going to set up another layer of loop, which is going to be looping over the second dimension here, if I can say it like that. So we're going to set up another iterator, which shouldn't be the same name as I here, because I is in scope. If we try to redeclare it, we will have a problem. So we're going to say for size t, and we're going to call this J. You can call it whatever you want, but J is a good convention we have in the C++ community. We're going to say J less than the dimension we have here, so we're going to say J less than 4. I am using hard-coded values to make it simpler to explain, but we're going to change this in a minute, don't worry. And we're going to increment our iterator, which is J in this case. Okay, once we are in here, we can access data in our array using multi-dimensional angle bracket syntax here. So what I am going to do, I am going to say stdc out, and I am going to say packages, and I am going to pass the first index, which we get from the outer loop here. So we're going to use I, and we're going to put in the second index, which we get from the second loop here, the nested loop, and it's going to be J, and it's going to be looping through the elements in the array. Let's put a space here so that we can separate these elements, and we're going to put our semicolon. Once we do something like this, we will be able to loop through the elements in this array here and print them out. Let's run this thing so that you can see what we get from the console. So we're going to bring up a terminal window like we always do, and we are going to build with GCC. Let's do that. The build is going to go through. This says that whatever we have been doing at least is valid. Syntactically, C++ is going to understand what we just did. Or I should say C++ compilers, they should understand the code we have in here. We're going to go in our terminal and clear and run Rooster. And notice that we have, data we didn't put in here because we didn't initialize this array. So this is junk data, but we should at least have 12 things in here. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are our elements that we are accessing using the multi-dimensional angle bracket syntax here. And this is really cool. So you can treat this linear structure we have in memory where we have 12 locations for ants and manipulate it using a 2D-like syntax here. And this is really cool. So now we have a way we can read data from our array. I don't really like having something that is uninitialized. So we're going to go ahead and initialize this using the syntax we saw in the slides. We're going to go ahead of ourselves here and do that so that we can have something nice to look at. So we're going to say packages again, and it's going to be 3 layers of 4 things. And what I'm going to do is put a pair of curly braces. I'm going to end this with a semicolon, and I will have 3 things that in turn contain 4 things. So what I am going to do is put a pair of curly braces here, and separate them with commas like this to really reflect what we have in our declaration here. We're going to have 3 things. So let's put in 3 things. And each of those things is going to contain 4 things. This is really what we are saying here. So we're going to say 1, 2, 3, 4 things, and we're going to say 5, 6, 7, 8, and we're going to put another 4 things down here and say 9, 10, 11, and 12. So we will have 12 things in here, and if we print our data, we should see the numbers here printed out. Let's try and understand what is happening here. We have 3 levels of 4 things. So 1, 2, 3, and each of those things is going to contain 4 things, and you can see that here. And this syntax is really cool. It's easy to understand, and it's easy to use when you want to initialize things like this. And you see that Visual Studio Code is not complaining. This might be good. It might work right. And if we try to compile this, the compiler is going to be happy, the build is going to be good. We're going to clear and run Rooster, and you're going to see that we have our data in here. So if you like what you see here, that's fine, but I think sometimes it is easier to break this into different lines so that you can really see that you have a 2-dimensional data structure. So what I am going to do after I have printed the inner layer here is go out of the inner loop and print a new line character. So what I am going to do is say stdc out stdendl, and you're going to see what this is going to do. It's going to go in and print the first line, which is going to be 1, 2, 3, 4. And after that, it's going to go and print the second line, which is going to be 5, 6, 7, 8. And after that, it's going to go and print the third line, which is going to be 9 all the way to 12. This is what we're going to get. So let's bring this up so that we can see our thing clearly. We're going to run Rooster, and this is exactly what we have here. I like this thing. And you can align these things, but we're not going to go that deep. We're just interested in getting the data printed out, and we have done that pretty well so far. So this is the syntax you can use to access data in your 2D data structure, which is represented by a 2D array that we have here. I hope this makes sense. Okay, this code is working, but we have a problem. We are using hard-coded values in here. This is not good, because if I decide to change the first dimension to 7, for example, then I will have to go and change this loop here. I don't want to do that. I want the loop to pick up whatever information is encoded in this array and use that without requiring me to go and change the loop. And we have seen a way we can do that. So what we're going to do is copy this loop, and we're going to comment it out quick and say that we want to use std size, and we're going to go down and put in our loop here. And we don't want to hard code these values, but we can ask the array and tell it to give us its size, and we can do that using std size. So we can say I less than std size and say packages, and it is going to give us whatever dimension is the first dimension here. And for the inner loop, we will have to be resourceful and target the second dimension here. And the syntax we have in C++ to do that is say std size, and we're going to say packages, but we will target whatever dimension we are in by passing in the current iteration. And this is going to give us the size of the things that we have inside this array here, if I can say it like that. First, you see that Visual Studio Code doesn't have a problem, so it might work, but we need to run it through the compiler to know that it has no problem. So let's do that. We're going to build with GCC, and looks like the build is good. If we clear and run Rooster, this is going to give us exactly the same thing we had, but now we are doing things better. We are not using hard-coded values, and if any of these dimensions happens to change in the future, our loop is going to pick that information up and print information exactly the way we would want. This is really cool. So starting from now, this is really what you should use in your C++ code. You should not use hard-coded values like we did here. Now we have played with a 2D array. Let's see how we can do the same thing with a 3D array. So we're going to declare and initialize it because we don't want to have junk data, and I am going to put in the data because I don't want to type all these things, but hopefully you're going to understand. So let's close this pane here by clicking on this file icon. This is going to give us a chance to be able to see whatever is in here. And this is the syntax we use. We're going to use 3 dimensions, 7, 5, and 3. And what this means is going to have 7 things. And if you count, you're going to find 7 things in this array. It's not all visible, but it's there. And each of those 7 things is going to contain 5 things. If we count 1, 2, 3, 4, 5, 5 things, each of those 5 things is going to contain 3 things, and it is what we have here. And the number of elements in this array is going to be 7 times 5 times 3. If you do that, you're going to get the correct number. And this is really how we declare an array of 3 dimensions and initialize it. Now we would want to print all the elements in here. So what we're going to do is type this out. We're going to say for size t, exactly the same thing we did for 2D, but now we're going to be extending this to 3D. Our iterator is going to be I, it's going to start from 0, and we're not going to use hard-coded values, so we're going to say std size, and we're going to say house block, and we're going to put in our incrementation part. We're going to go in and put in our second layer, and inside we're going to say for size t, and we're going to use j as our iterator. This will work. And we're going to put in our test. We're going to say j less than std size, and we're going to target the second dimension. And the way we do that in C++ is house block, and we're going to pass in the iterator we are at in this first loop here. So we're going to say I. And the moment we do that, this is going to work just fine. This is just multidimensional array syntax we have in C++. You just have to stick to this and you're going to have no problems. So we're going to do our incrementation inside the second loop. The iterator is J. We're going to go in the third layer because we have 3 dimensions. Let's go down again. And we're going to say for size T, and we're going to say K. You can name this whatever you want, by the way, but I am using IJK because they are pretty common in the C++ community. Okay, we're going to put a semicolon and put in our test. K is going to be less than std size, and we're going to say house block, and we're going to put in the 2 iterators that we have so far, I and J. So we're going to say I for the first dimension and J for the second dimension, and this is going to be our test, this entire thing here. And after that, we're going to put a semicolon and increment our iterator, which is K. And after we have this, we're going to jump into the meat of this loop here, which is really printing the data. So we can do stdc out and say packages, no packages, house block, sorry for that. And we're going to pass in the indexes that we have. The first one is going to be I, the second one is going to be J, and we are going to get the element of interest here. Let's try and put a space here so that they are separated. We can see that on the terminal. Okay, let's try and run this and see if the compiler accepts whatever we have been doing here. We're going to build this, and we're going to clear. The build is good. We're going to run Rooster, and you see that we are printing all these numbers here. The first one is 1. The last one is 105, and you see that we have the data, but it is really cramped because, again, hopefully this proves that the data is really a linear dump of ones and zeros, and in this case we happen to be interpreting the data as integer. We are grouping the data in 4 bytes and treating each of those bytes as one thing, and we are printing it out here 1, 2, 3, 4, and this is really what we have here. If you want, you can format the data however you want, but it's really not easy to visualize 3D data on the console like this. So I am going to just go this far and show you that you can access the data. And this is really all we set out to do here. Okay, now that we have this working, we're going to go a bit faster. And let's comment this out because we don't want this to disturb us in what we are about to do. What I am going to show you now is that you can omit some dimensions if that's something you want in your application. So what you can do is something like this. You can declare a dimension and store that in a variable. Remember to make it const because sizes that your array uses are expected to be const. If you don't do that, you're going to get a compiler error. Let's actually try and take that out, and you're going to see that Visual Studio Code is going to probably complain. Yes, it is. You know, the size must be const. This is really the problem here. This size that we passed here must be const. If we make it const, the problem is going to go away because this is what the compiler expects. But what we really want to talk about here is this first dimension that we have omitted. We can omit this out and let the compiler deduce it. The compiler is going to look at whatever we initialize our array with, and it's going to count groupments of 3 things we can have in this array here. And it is going to get 1, 2, 3, 4, 5. It's going to say, aha, the first dimension here is 5, and that's what it's going to use. And you see that we don't even have to care about that when we print the array here because we are using std size. Std size is going to pick whatever size we have here and use that to print data here. And if we try to print this array here, we're going to build with GCC. The build is going to go through, and we're going to go down and clear and run Rooster, and we're going to get our elements here. They are printed out. Only now we are trying to put them on different lines, but this is really a preference thing. You can do this however you want. You see that it is the data we had in the array here. Okay, you can omit stuff, but you can't omit the second dimension here. If you do that, your compiler is going to go crazy and ask you whatever it is doing because based on the information we have here, we can't really know how many elements you want in each groupment in your array. Okay, so the compiler is going to see we have 12 things in here. 12? 1, 2, 3, 4, 5. We have 15 things in here. This might be 3 things grouped in 5 rows, so the compiler doesn't really know. So you need to tell it and give it a hint. And if we say that the second dimension is a 3, it's going to know that we're going to have 5 things, and it's going to figure that out. I hope this really makes sense. Let's comment this out and also see that we can omit things for 3D arrays and show you how that works. I think it is better to learn through examples like this because you have something you can run through the compiler and you're going to try and figure that out on your own. So here we have a simple array, it's called HouseBlock1, and we have omitted the first dimension here because the compiler can deduce the number of things we have in here and fill that in. And it is something you can do, but you can't really omit any of the other dimensions. If you omit this, the compiler is going to go crazy and not really know what you are doing here. You see we have a squiggly line, and if we bring this up and look at the problems tab here, an array must not have elements of this type. So the compiler is really confused. If we try to compile this, it is Visual Studio Code that is confused here. Sorry for that. And the compiler is also not going to be happy. It's going to say declaration of the array as a multidimensional array must have bounds for all dimensions except the first. So this is super clear. So we need to put this thing back in. And then the compiler is going to be happy. And once we have this, we can really print this out. We're going to see the data printed out and the compiler is going to be happy. I am going to go ahead and go down and put in the code to print this array. It is nothing you haven't seen. It's what we have been doing all along. So if we compile this with GCC, the build is going to be good. Build finished successfully. You can go here and clear and run this, and we're going to get our elements grouped in groups like this. And we are formatting the data in here to show up nicely like this, but the bulk is the same. It is the same thing we have been doing all along. STD size, house block, we pass in the index we have and the current iteration. Let's bring this back. We just messed it up. If we go inside, we are saying house block I and J, and we print whatever data we have. We are just formatting these things so that we can see them in angle brackets like this, but it is the same thing we have seen all along. The other thing we really want to play with is autofilling and show you how the compiler handles that. If you pass in less elements than you declared in your multidimensional array declaration, the compiler is going to autofill in the missing slots. For example, here we declared an array of, it's going to have a number of things in here, but each of those things should have 5 things in. So we should have 1, 2, 3, 4, 5 things in here, and this is right. And each of those 5 things should have 4 things inside. And you see here, this is really not we have 3 things in here, and here we even have 1 thing. So if we print this out, we should expect the compiler to autofill in zeros. It's basically going to add a 0 like this. But we're going to let the compiler put that in here, and we're going to be able to see that when we print this out. So we're going to build with GCC. We hope the build is going to be good. It is good. And if we clear and run Rooster, you see that it has autofilled in the 0 here. And for the 4 that we put in here, the compiler has also autofilled in zeros. And you see that the entire thing has been autofilled with zeros. And this is really cool. This is something you might take advantage of in your application. And again, the printing here is something you already know, so we're not going to try and explain this. The last thing I want to show you is that we can modify data in our array, and we are going to be using the same syntax we have seen here. So for example, if we want to modify this 8 here, we're going to target it with the first index. The first index is going to target this thing here, and we're going to use index 0 because it is at index 0. The second index is going to be 0, 1, 2, and the third index is going to be 0, 1. So we can say house block, modify data. We're going to say what we want to do, and we're going to say house block, and we're going to target the first index is going to be 0 because it is the first thing we have in our array. Again, we want to target this 8 here. The second dimension is going to be 0, 1, and 2. So we're going to put that in. And the third dimension is going to be 0, 1. And we're going to make sure that is shown here. So we're going to say 1. And we can assign a value to this. We can, for example, put in 1021. Not 1021, 1021. This is going to do. So in this location here, we expect to see a 1021 because we just changed that. And this is the syntax we can use. We're going to build this with GCC. Let's do that. And we're going to go down and clear and run Rooster. And you see that the number just changed to 1021. And this is really cool. This is really all we set out to do in this lecture. I apologize it turned out long because we really had a lot of things to talk about. Multidimensional arrays can be confusing to many people. I hope I made that clear to you and gave you a lot of examples that you can really play with to drive the point home. We are going to stop here in this lecture. In the next one, we're going to learn about multidimensional arrays of characters, and we're going to see how special they are. Go ahead and finish up here and meet me there.